Hello and welcome to this quick introduction on coordinate geometry. First, let's look at the straight line equation in the form ax plus by plus c. We can use this equation to find the gradient, the x-intercept and the y-intercept. To find them, you can use these simple equations. For the gradient, it's minus a over b. For the x-intercept, it's minus c over a. And finally, for the y-intercept, it's minus c over b. Note how the coefficient is the denominator for the x and y-intercepts. For those interested in derivations, you can make y or x value equal 0 and rearrange to find the x or y value respectively. Normally, you will be asked to use the line equation to sketch the line on a graph. Over here you can see I've quickly drawn a graph. In order to draw a straight line graph, you need 2 points. In most cases, the x and y-intercept is used. Then you simply join the 2 points together. But what happens when the x and y-intercepts are the same at the origin? You must now use the gradient. Once realized, you can roughly draw the line going through the origin. Moving on, let's look at this equation. This is used to find the line equation going through 2 points, x1, y1 and x2, y2. To help us understand this equation, we will use these 2 points as random points on a graph. Thus, we have a line. Next, we will take a third point on this line, with coordinates x, y. We can then draw 2 similar triangles, with its difference in y coordinates as one side, and difference in x coordinates as the other side. As you can see, it's a right angled triangle. Let's remove these 2 triangles. The hypotenuse's gradient is the same for both these triangles, since they lie on a straight line. So if we use the fact that change in y coordinates divided by the change in x coordinates is the same for both triangles, we get our original equation. It may be hard to recreate those steps in an exam, so you will probably want to learn this equation. The easiest way to remember it is that both fractions end in the same way, something minus y1 over something minus x1. You can also use the pattern that each of the x coordinates is directly under its respective y coordinate, and thus you can fill in the leftover parts. Moving on. Here is one last line equation which you may not have come across. This is to be used when you know a gradient and the coordinate. You can derive this equation by simply using the same rule for gradients. The gradient equals the change in y over the change in x. The questions they normally ask to confuse you is to often make the gradient a fraction or negative. Let's do a quick example. If a line has a gradient minus 3 over 7 and goes through the point 8, 5, what is its line equation? Have a go by yourself. The first thing you should have done was to substitute in all the values. Now the trick for doing these fractions is to multiply the denominator 7 out of the fraction and onto the other side. Beautiful, no more fractions. Now the problem that some people have is when multiplying negatives, they often make mistakes. To avoid this, just take it onto the other side. Finally, multiply out the brackets. Then add up the remaining numbers, and voila, 7y plus 3x minus 59. Well done if you got that at home.